recording the session. Just remember, right, today what we're doing is we're doing lesson 4, application of rates. And I'm going to record the session, post it down here as a link, just like I did yesterday. So this is the link for yesterday's session there, okay? So remember, follow along with where I am so that you can do the tasks as I'm doing them and stop asking if you have any questions as well, okay? So today we're working on applications of rates, right? Where we talked about so far ratios, then we talked about rates being a ratio that has different things that you're comparing, and now we're going to talk about how you actually apply those rates to different scenarios. So it's not going to be too far removed from what we actually did yesterday and the day before, but it's just kind of reinforcing those ideas of how we apply those rates, right? Good morning, Shiloh. So it says, in this lesson, you will solve unit rate problems, including those involving unit pricing and constant speed. All right, check in the bedroom. I'll use that one right there, the pink one right there. Sorry, guys. So again, we're looking at unit rate problems. Remember, when we say something is a unit rate, that just means that one of the units is 1, all right? So like miles per 1 gallon, dollars per 1 hour, those are all examples of unit rates. Right, so let's get to the first slide. I'm gonna just read through the scenario here and then kind of explain what they're talking about here, right? It says, Janelle and her family are traveling around Europe. They're spending a few days in Spain and plan to travel to France, Switzerland, and Italy later. When they take a train from Madrid to Barcelona, Janelle asks her brother Andrew, how long will the journey take? Andrew tells her that they will reach Barcelona in 3 hours. So they will reach Barcelona in 3 hours. Let me just highlight that. That's a time that's going to become important a little bit later. It says Janelle is surprised to see that their train reaches Barcelona in 3 hours. So he told her it's going to take 3 hours. It actually took 3 hours, just as Andrew said. She wonders if there's a relationship between the distance traveled and the time taken, right? So we actually already discussed that relationship yesterday, the relationship between how far you go, your distance, and how long it takes, time, we call speed, right? So that's what we're going to be talking about today, and speed is an example of a unit rate. It says in this lesson, you'll relate the distance traveled to the time taken using a rate. You'll also study how rates apply to other everyday situations. Watch the video on the next screen, how a rate can be used to find the speed of a train. All right, so we're gonna watch that video together. Again, if sometimes these videos, when I play them on Zoom, they come out a little choppy. So if you're finding that it's not really that viewable for you, you should also have Edmentum open at the same time, and you can just watch it on your end while I play it here, all right? It's about 1 minute long.
Many types of rates. One of the most common rates is speed. An object's speed is the distance it travels over 1 unit of time.
Right, so this formula here is something that you're gonna definitely wanna try to remember, right? It's gonna be given to you right now in the 6th grade, but moving forward in any math class that you take in the future, once you start taking science classes, this is something that pops up a lot. Speed is defined as distance divided by time. So how far you went divided by how long it took you to do that is going to be how fast you were going.
We can use this equation to find an object's speed. Let's look at an example. Janelle is traveling by train from Madrid to Barcelona. She knows that the distance between these two cities is 390 miles. Because she also knows that the train covers this distance in 3 hours, Janelle can find the train's speed using the speed formula. She divides the distance traveled by the time it takes to get from Madrid to Barcelona. Let's look at the map to see if this calculation makes sense. The distance between Madrid and Barcelona is 390 miles, divided by 3 hours of travel. Each hour, the train moves a distance of 130 miles. So the rate of travel is 130 miles per hour. Next stop, Barcelona.
All right, so could you guys just let me know in the chat if that part of the video made sense there, where they talked about how they found the speed and then
Manny,
breaking it
Madrid
up. So
and
I'm just gonna
Barcelona
fast
is
forward
390 miles,
a little bit.
divided by 3 hours of travel. Each hour, the train moves a distance of 100.
Right, so at this point here, they're basically saying that what we have right here, right, 390 miles per hour. So this distance here is 390 miles. It took 3 hours to do it. So what that means is that each hour, let's say from here to here, that's 130 miles in 1 hour. The second hour from say here to here is another 130 hours. The last section, again, would take another hour. That'd be another 130 miles. So altogether, they traveled 390 miles in 3 hours, right? And I see people responding in the chat. Okay, how did she get 390 and 3 hours from, right? So it was, this first part was given to us. It told us that the train went 390 miles. So from Madrid to Barcelona over here, we know that that distance, right, from here to here is 390 miles. If you look on a map, you would see that, right? And then we know, right, it told us on that first slide that they took a train, and it took the train to get from here to here 3 hours. So we then used that information to try and figure out what the unit rate was. So we figured out that the unit rate has to be 130 miles for every 1 hour. So 1 hour, we go 130 miles, we're a third of the way there. The next hour, we go another 130 miles. The next hour, another 130. And that takes us from the start to the finish place. Okay, good. So how did she get the 130? The way she got the 130 is by simplifying this ratio. So 390 miles divided by 3 hours. Basically what you do here is you just divide. So if you take 390 divided by 3, you get 130, right? We're simplifying that fraction. Another way to think about it, just divide it basically. That's the easiest way to think about it. In some cases, if you can't get down to 1, you would actually have to simplify, but you're really just simplifying here. Right, I appreciate the question, so I can try to clarify things up for you guys. Right, and I think the next page is actually going to give us another example to try to work on ourselves. All right. Okay, so hopefully we didn't see that. I don't know why it defaults to showing you the answer. All right, but we're going to work it out anyway. All right. It says Rosemary drove from Philadelphia, Pennsylvania to Pittsburgh, Pennsylvania. So let's just, it helps sometimes in math problems to give a quick picture, right? So let's say it says she started at Pennsylvania. Actually, we'll say Philadelphia, right? They're both in Pennsylvania. So she's in Philly right now. She's moving to Pittsburgh. So this is the direction that she's traveling. Starts at Philly, ends at Pittsburgh. Now, we need to know a couple of pieces of information to figure out the speed, right? To find the speed, we always need to know two things. We need to know how far she traveled and how long it took her to travel that far, right? So in this question here, how far is it saying that she traveled? Right here, it says that she traveled 305 miles. So let me just add that into my rough diagram here. So she went for 305 miles. And then it says that that trip took her 5 hours. So to go from here to here, it took her, right, Penelope, go sit over there, please. I know, but your iPad's too loud. So 305 miles from here to here, 5 hours. When it's asking us here, it says, what is the speed at which she drove the car? Basically what that's asking us is, how far did the car go in 1 hour, right? So we want to know in 1 hour, how far is the car able to go, right? And I think that I already saw some people writing stuff in the chat. I don't have it open right now. Okay, good. So Alfie in the chat, he said the answer is 61 because 5 times 61 is 305. Okay, so that does work, right? If I was to go ahead and say 61 multiplied by 5, I know 60 times 5 is 300, plus the extra 5 gives me 305 miles. So that's kind of like a way of checking your answer, right? Or if it's multiple choice, you can always work backwards, right? You could say, okay, so let's say it was going 81 miles per hour. If I did 81 times 5 hours, that's going to be 8 times 5 is 405 miles, right? That's way too big. If I did the same thing with 50, I said, okay, let's try 50 miles times 5 hours. That's going to give me 251 miles. That's not far enough. Same thing with this one here. I'm going to get something that's not far enough. This one is the only one that works, right? But if you want to think about figuring it out like the way it showed us in that video, all we have to do is remember that speed is defined as distance over time. So how far you went divided by how long it took you to go there, right? That's simple. So in this case here, we say the distance, they traveled 305 miles divided by, it took her 5 hours to get there. So I can see here my answer is 305 miles over 5 hours, and you simplify that or simply just divide. So 305 divided by 5, like Alfie gave us before, is going to be equal to 61, and I have the same unit. So 61 miles over hours, or miles per hour, right? We see miles / hour. Those are our units. They tell you what to do. So if you just look at your units, this tells you, okay, I need to divide miles, or I need to divide a distance by a time. So if you look at your units, you can kind of reverse engineer and figure out what you actually need to do to solve that question. Right? I'm just seeing some stuff in the chat. I'm going to check that really quick. Okay, okay, good. Just let me know if you have any other questions here. Hopefully that made some sense. Okay, so let's look at this next one over here, right? It says, you can find the distance between two places if you know the speed and the travel time by writing the formula for speed equals distance over time. So that distance is on the left-hand side, distance equals speed times time, all right? So basically what this slide here is telling us is that depending on what information you know, you can figure out the other ones, all right? So I know that speed equals distance over time, right? So if I know how far I went, I know how long it took, I can figure out how fast it was going, right? What this here is basically saying is depending on what other information you have, it's possible to instead figure something else out. So give me a second, just adding in some late people. All right, so let's go back to this last one that we just did, right? So this here would be like saying in this example here, I know that the car is traveling at 61 miles per hour. So the speed is 61. Let's say I also know the distance. I know that it is going for 305 miles. So I can use this information, how far I need to go, and how fast I'm going to actually also figure out how long it's going to take. So that would be like saying a different question, right? Saying, okay, a car is driving for 305 miles. It's traveling at 61 miles per hour. How long does it take to get there? So we're still using the same information, right? Or sorry, with the same relationship that your speed is equal to your distance divided by the time. But instead of working with the distance and time, instead I know the speed and I know the distance. So if I work with those same things, I would go ahead and do that, right? I would take the speed of 61 miles per hour, replace it with this side of the equation, replace the distance of 305 miles over here. What that would turn into is that 61, my speed, is equal to the distance, right, which is 305, divided by the time. The time we don't know yet, right? Now, the way mathematically that I would work with solving this equation, and I'm not your guys' regular math teacher, I'm not sure what techniques you've been taught in the past, right? One trick that is sometimes used is something called cross multiplication, right? I'm not sure if we have learned that yet. So we would basically multiply, right? This is kind of getting more into algebra. So let me just back up a second. I don't want to confuse you guys too much, right? We would just know that, basically, if I want to rewrite this equation to find time, time is equal to distance divided by speed. Right? So basically, I'm swapping the order of these two. I'm switching the speed and the time, and that's going to keep the relationship the same. Right? But I don't want to confuse you. It's going to be a whole other separate lesson going over cross multiplying, solving this. So ignore that. Use this equation here. Right? So I would just say the distance is 305 divided by how fast we're going, in that case, is 61. If we divide that, you end up with 5 hours. Right? So these relationships should be given to you when you're answering these. So speed is divided by time. The time is just your distance divided by your speed, right? I don't want to confuse you any more than I have to, so we'll leave it at that for now. All right? So looking back at that relationship there, was there an actual question on the next slide? Right, so I gave us an example here. It says that Theodore is riding a bicycle at a speed of 15 miles per hour. That's his speed. And it says we'll find the distance he covers in 5 hours. So now this is another relationship here. So distance you find by taking your speed and multiplying it by how far you went, right? So if his bike is going at 15 miles per hour and he's traveling for 5 hours, right? Hopefully this is one that just makes sense to you, right? So think this is his bike here. He starts here. After 1 hour, he's gonna go 15 miles. Second hour, he goes another 15 miles. Third hour, he goes another 15 miles. Fourth hour, another 15. Fifth hour, another 15 miles. So this whole thing here is how far he's gonna go in 5 hours. And it's really just 15 plus 15 plus 15 plus 15 plus 15, right? But this is here a little cumbersome. You're not going to sit there and keep adding 15 up. The fast way to do this would just be to say, okay, so 15 miles per hour multiplied by 5, right? That's going to give you the same result of just adding it up 5 times. So if you know the speed, you know how long you're taking, you just need to multiply the two, right? The other one, to find the time, this is this formula that I just went over on that last page. So you take your distance divided by speed, right? Throughout this lesson, you're basically using 3 different relationships, right? Let me just, again, review those really quick here. The first one is that speed is equal to distance over time. The next one is that distance is going to be equal to how fast you're going multiplied how long you went for. And the last one right here is that your time is equal to the distance divided by how fast you went, right? Again, they all kind of stem from this relationship here, but just kind of based on your understanding of some simple algebra concepts. It might be hard to figure out how you actually get these or why they're the same. But for now, just focus on using these. All right. So that's pretty much it for this portion of the lesson. The next slide should be an activity. Okay, so we've got a question that you're going to answer this one yourself, try to figure it out based on what we've done so far, and then just continue working through the lesson. All right. But I'm going to stop here for now with the live portion of the lesson, let you guys continue. And again, we've still got more than 20 minutes of live classes available. So as you're working, you're going to be here. Let me know if you have any questions as you go.